Hey everyone, so today we'll be looking into the next part of object-oriented programming, which is inheritance. Now, what do we mean by inheritance? So, inheritance basically means to inherit something, that is to take some like something from someone, right? So we have to focus on this word, okay? Inherit something. Inherit, you can think about inheriting property from your father, or your father inheriting property from your grandfather. Let me give you a quick example. So what is inheritance in object-oriented programming? We'll come to it later, but let's first understand in basic layman terms what does inheriting means. So let's say this guy, yeah, that's you, okay? Now, okay, let's start from here, by the way. Say this is your grandfather, alright? Your grandfather has one farm, a big farm, okay? You have your grandfather has a big farm. Great. And this is your father, that means his son, right? This is your father, that means his son. Great. He gets the farm which was originally belonged to his grandfather, right? This farm, it was his father's, but he got it. This is called inheritance. And later on, the son, or like your father, purchases another building as well. Okay, this is his own property. But by the way, this farm, he is getting it in inheritance. He is inheriting this. Properties are inherited, right? Inheriting. Okay, then you are the grandchild of your grandfather. Basically, you are the son of your father. Great. Now your father inherited the farm from your grandfather, and he purchased his own buildings. Now you are inheriting the farm from whom? From your father. And how are you doing it? Well, your grandfather gave the farm to your father, and your father gave the farm to you. So you got the farm, and you got the building as well. This building as well. So this is inherited, and this building is also inherited. And then you purchased your own car. This is your own property. But this is your father's this is your yeah, technically your father's property, because your father inherited this from your grandfather. So yeah, this is an inherited property, and this is also an inherited property, just like your father inherited the farm from your grandfather, right? Okay, let's see some other example as well. Say your grandfather was able to play the flute, okay, and then he had his son. His son could play harmonium, but he could also play flute. And how did this come? Inheritance. His father knew how to play flute. He knows how to play harmonium, but he also knows how to play flute. Why? Because this ability was inherited from his father. Now this is you. You can play guitar, but you can also play harmonium, and you can also play flute. Why? Because this property is inherited by your father from your grandfather, so you can automatically inherit this property. And this is technically your father's property, your father's ability, so you can inherit that too. Okay, so this is how you can inherit the abilities. And by abilities, I mean, in programming, methods. You can inherit methods, and these are the properties that you can inherit, right? Your grandfather's farm was inherited by your father, your father's building was inherited by you, and your grandfather's farm, you also inherited that as well. So this is how you can inherit properties. And what do we call properties in programming? Attributes. So basically, think of everything as in class. Grandchild is a class, son is a class, grandfather is a class. Grandfather has some attributes, a farm, and he has a method called playFloat. Then son is another class. He has his own property, say this building, and his own ability, I mean method, that is play harmonium. But the moment the son inherits properties and methods from grandfather, he gets this farm, which was originally a property of his grandfather, and the ability to play flute, which was his grandfather's, of course. Then you are also a class, and you are inheriting your father. You are inheriting your father. You are not directly inheriting your grandfather. You are inheriting from your father, and you are again getting you're getting the farm, and you are getting the building, and you have the car. These are all your attributes, and these two were inherited this from your grandfather, I mean not directly but indirectly by your father, via your father. And harmonium, which is directly by your father, and you can play guitar. So these are your methods as well. So now coming back, what is inheritance in context of object oriented programming? Inheritance means the ability of a class to inherit methods and attributes from another class. Simply, that's it. And why do we need inheritance? To write less code, reducing the number of duplicate lines. Okay, for example, say I wanted this guy to play flute and harmonium and guitar. How would you originally do it? How would you originally? You would write a class. You would write 3 different methods, right? What are those methods? This method, this method, this method. Say this method takes 4 lines, 4 lines, 4 lines. How many lines did you just write? 12 lines. You wrote 12 lines of code. Okay. But if you are inheriting from your father, you are inheriting your father, and your father is inheriting from your grandfather. Say this function has 4 lines of code. This function did not need any line of code. Why? Because you inherited. This is already written. You are just reusing the function. You don't need to write it. You just need to define your own method. This class's method, which is play harmony. So this is 4 lines of code. Great. Now you are inheriting say this and this, play flute and play harmonium. So you don't need to write 4 lines. You don't need to write 4 lines. You just need to write this 4 lines. Now do you understand how we are reusing the code and we are saving lines of code? Exactly. And you will understand more when I directly show you the examples. Okay, let me go with the first very basic example, a student and a human. Okay, all right. So we'll have a human.java class. Okay, human.java, and we will have a student.java. Okay, and of course we'll have a test.java or something, maybe entry.java, whatever, where we'll have the main method, and we can of course create the objects and play around with it. Okay, so yeah, perfect. Let's create it quickly. And yeah, this is the this will be what the constructor would be look like. That is human. It will have a name and it will have a location. That's it. Okay, sorry, address. Yeah, name and an address, both are strings. And human will have 2 methods, eat and sleep. Now interestingly, the moment student inherits the human class, automatically it will get these 2 methods. You don't have to write 4 lines of code for all these things. You don't need to. You just need to define your own method, which would probably take 2 or 4 lines, whatever, and it will automatically get these properties. Of course you can I mean define whatever name you want to give over here, but it will get this automatically. You don't have to write separate, like you don't have to, when you're defining student, you don't have to write string, name and address. You don't have to do that. This is already written inside this human class, and you are just inheriting it in the student class. Okay, cool. And you just have to define your, of course, your own properties. That's it. So let's quickly do this. Okay, by the way, very important, we'll be learning about something as superconstructors. We have constructors, we'll have superconstructors as well. Let's see this in action. Let's quickly open up our BlueJ. Today I'll be coding in BlueJ probably. Let's do it in BlueJ. Okay, great stuff. And let's delete all of these things. I don't need all of these at this moment. Just quickly delete it. Delete button does not work. Lol. Yep, just remove them. Yeah, let's create a new class. Let's start fresh. Let's say human. Human is our class. Let's create another class which will be our student class. Let's create another class which will be our entry point. Entry point, I mean, this is where, this is the file which he will be running. Okay, entry point. And let's start coding. Let's keep it separate because entry point is where your program starts. And let's keep human over here and student over here. Okay, this looks neat, that's why I'm doing this. All right, so first things first, write the entry point first. What is the entry point? Nothing, just a main method, just an empty main method. This is where your program, this is what you will be running directly. So public static void main string main string args. Simple. For now, just save it and compile this. Yeah, okay, this is done, and close it. Okay, it's just a main method, you don't do anything over here. Let's define the human class first. Let's do this. Okay, remove all these things, you don't need this. Remove everything. Okay, now again, as I said already, don't write a main method over here. This is not that you will run directly. This is not something that you will be running directly from BlueJ or from any other editors, right? This is just a class. Just define it like a class. So what are the properties that the human will be having? Human will have a name and an address. Done. Of course, make it public. For now, let's play around with public. Then we can of course do the getters and setters and stuff. But we don't need this, at least for inheritance part. We need protected and other things. So we are good. All right. And human has two methods, namely public. Okay, let's put it over here. Yeah, public void eat, and say he will eat some food, right? The food name will mention, and it will just print out system.out.println. Oh, sorry, I forgot to make the constructor. Lol. Let's first create the constructor. Let's create the constructor. Yeah, so the constructor would be public human. Now, why am I writing public human directly? You could have avoided. You could have avoided, and I'll show you the reason. But okay, let's avoid it for now. We have this human constructor. It will take two values, the name and the address. So let's give it a string name, string address. Oops, address. And yeah, just add an underscore just to differentiate between the parameters and the arguments. Cool. Now simply say this dot name is equals to underscore name. This dot address is equals to underscore address. Simple. And yeah, also just print it out. Okay, just say system.out. Oopsie. System.out.println and say student and print out the name. This dot name. I should add a space over here. This dot name plus say, oh, I'm not creating student, am I? I'm creating human. My mistake. Human in and I'll give the location as well, this dot address. Created. Okay, simple. That's it. We're done. Great. So say I give it Pritam and Mumbai, it will say human Pritam in Mumbai created. That's what we're going to see. And it has two methods, namely eat and sleep. So the first method is public void eat string. I'll say I'll give some food, and it will simply say system dot out dot print ln, and I'll say a human is eating a human, or I should specify his name as well. Rather, yeah, I should. Human space the name of the human, this dot name now is eating whatever the food that the user gives. I'll just use the argument simply food. Not this dot food, okay? This means the property of the object. Food is not the property of the object, right? Food is just an argument that I'm passing in this method. So yeah, just food. Taking this, and another method, say public void sleep, and say int hours, how many hours he is sleeping basically. And again I'll say this system dot out dot print ln a human is, okay, again let's just write this dot name this is sleeping for some hours, whatever the hour we pass in, hours this I'll just write, yeah, 5 hours, right? 5 would be the hours argument, and space hours. Okay, that's it. Let's first play around with human, this human class. Okay, let's play around. Let me open entry. Oh, I didn't compile this. Let me compile this first. Class compiled, no issues. Let's open the entry point here and simply write human h1 is equals to, I'm calling the constructor new human, and we have to pass two things, the name, say I'm passing Pritam, and I'm passing the address as Mumbai. Okay, pretty cool. Let's compile this. This works. And also do one thing, h1 dot eat, and I'll write pizza. I'm calling the method, I'm calling the non-static method. So the human h1 is, that's why I'm using the dot operator. H1 is eating what? I'll pass pizza probably. And did you see entry point is using this class, that's why it is pointing an arrow to this. Anyway, let's just do this. Compile this. Perfect. Let's run this. Wait a minute. Boom. So did you see what happened? The first thing that happened was that the constructor showed up human Pritam in Mumbai created. Okay, it created the object. The first line created the object, and who created the object? The constructor, of course. Then you are calling h1.eat, and you are passing in pizza, so it is showing up human Pritam is eating pizza. Okay, that's how it works. So perfectly alright, what we expected. Now let's create a student class. Remove all these things, and okay, what would be the student properties? Now interestingly, you would have to write name, address, role, and standard if you are just creating the student class. For example, if I had to create just a student class, I would have written string name, address. I had to write maybe standard, standard, and then I would have to write role. But I don't need to do that anymore. I can just say, I can remove all of these things. I can simply go here and say extends human. The moment I do this, yeah, okay, I'm doing this. Hold on, just hold on. Do you see this arrow? This is a different arrow. Do you see this arrow is different? This arrow is different. Why so? Because this arrow shows that I'm using a method of this class. Simply that. But this arrow is showing that I am inheriting the properties and the methods of this class. Do you understand? This simply means I am using the properties and attributes, but this shows that I am literally inheriting the properties and attributes of this class. So what I mean is this: you no longer have to do all that stuff. You just need to define only the specifics of student class. Say standard. Even standard and role are just integer, right? Yeah, public int role and std standard. Perfect. That's it. And that's it. See, I didn't have to go through the pain of writing string name and what was that, address. I didn't need to do that. Why? Because this is already defined in human class, and I am saying student is a human. Student is a human, and if student is a human, it automatically inherits name and address. I don't need to define it separately inside student. That's how it saves the number of lines of code that I'm writing. That is the main purpose of inheriting things. I don't have to repeat the things. Okay, now let's write the methods. First we need to write the constructor. Let's create the student constructor. Now interestingly, of course, a student, the moment I say student extends human, it means the student has a name and an address. So I have to take that also. I cannot just say a student will just take role and standard. No, student will also take string name, and student will also take, let's put an underscore, student will also take string address. Okay, it will take both, and where it will give, that's the question. Let me show you. Then it will take, of course, the int role, and it will take int standard. These are the student specific. Okay, these are student specific. Inside this, importantly, what will happen is this: I will call the human constructor. This constructor, I will call this constructor. Okay, how do I call this constructor from this from the student class? Do I write human like this? No, I don't. I will simply say super. Super means super constructor. I mean, yeah, it is of course the same as this, but I'm not creating the object. I cannot call this like that. Because otherwise I have to do new human and stuff, and that is wrong. This is wrong. You just need to say super. Super means you're calling this constructor. Okay, and what you need to pass in this constructor, the name and the address. Simply pass it. You have already taken this from the user, so simply put it here, and again put it here. Simply pass it to the human constructor. You're calling the human constructor. Okay, that's it. This is done. This is basically calling the super constructor. What is a super constructor? Super constructor is the constructor of your super class. What is a super class subclass? I'll show you. Okay, so let me go back once. Oops, where did I keep my pen? Yeah, we go. Now listen carefully. Student is inheriting human. Therefore, student is a subclass. Why? Because student class is inheriting. Inheriting whom? Inheriting human class. That's why human is the superclass. Do you understand the difference? The class that inherits is called the subclass. The class which is getting inherited is the superclass. Now, subclass will have a constructor and superclass will also have a also have a constructor. Okay, and this constructor has to call this constructor using the super keyword. It is essentially calling this constructor only, and the constructor of superclass that you are calling is called a what? This constructor now listen, if you are creating just a human object, you are calling the constructor, yes, it is a constructor, perfect. But if you are creating a student object and you are calling the constructor of the human class, that is the superclass, then it is no longer the simple constructor. It is called the super constructor. Do you get it? If you are calling the constructor of your parent class, this is the parent, okay? This is the parent class, and this is the subclass or the child class, whatever you call it. This is the parent class, this is the child class. Okay, now child class is calling the parent class's constructor. That is why the constructor of the parent class is called super constructor. Do you get it? Now how do we call it? Using the super keyword. Okay, I called the constructor of the parent class, which is the human class, and it takes name and address. I have passed it, and it will do its job. It will do its job. Oopsie. This is a human constructor. Okay, great. And for this class, what do I need to do? Simple. I would just say the things that we do. This dot role is equals to underscore role, whatever the user passes, and this dot std is equals to whatever the standard the user passes in, and we are pretty much done. Hey, what's up? Oh, I didn't put the underscore. Lol. Yeah, now it's good. It's good. And the moment this is done, just say system dot student. Let me put it over here. This looks cleaner, right? Yeah, this looks better. Yeah, student, whatever the name is, this dot name. Interesting thing is that I never defined any property called name, but it can still access this. Why? Because it is extending the human class, and human class has what? Human class has a property name. It can access name. Okay, although I haven't defined name specifically for the student class, but since it is extending the human class, it is already there, and I can access name and address. So I can simply say student this dot name created in class in standard. Okay, I need to maximize this. Yeah, in standard, whatever the standard is, this dot std. Now this I have defined. With roll number, this dot, and this I have also defined. So yeah, that's it. Student will have its own methods. Say study, simple. Okay, say it will have just only one method, public void study, and it will take in a subject or something. Say subject. Okay, it will take a subject. It will simply say system.out.println, and you can simply say student um, whatever the name is, this dot name. Now the thing that I want to point out again, I haven't defined anywhere name as the property of the student class, but it is still using the property of the human class. Okay, human class has name and address, and you can still access it within this class and outside of this class as well, because I have defined this as public. I can access it within this class. Of course, I'm accessing it. As you can see, I can access this and I can access this as well, but I can access this outside of the class as well. I will show you. So this dot name, and yeah, basically I'll just say is studying some subject, whatever the subject you are passing. That is not a property, you're just passing an argument. So simply subject, whatever the subject he or she is studying, right? Just put a semicolon and we are done. Let's compile this and let's see. Yeah, class compiled. Let's yeah, we're done. Alright, this is the entry point. This is the entry point. Currently we are directly using human, but let me modify things. Okay, let me just remove this and let me create a student class. I mean student object. Student s1 is equals to new student, and say I'll just say Pritam, and I'll say Mumbai. And just create that one only for now. Just create that. Oh, I need to pass two more things, right? Okay, it is expecting the name, address, and roll number and the standard, right? Oops, I forgot. So the roll number would be what? It is expecting roll number, na? Yeah, roll and then standard. Yeah, it is expecting name, address, roll, and standard. So name, address, roll number say 20, and standard say class 10. Save this. Let's compile this. And do you see the map? Do you see the map? Entry point is directly creating student object, which is basically inheriting the human class. Let's compile this. This is interesting. Okay. Compile and let's run this. Let's see what happens when we actually run this thing. Let's close this up and let's run this. Okay. Okay, look from here. Look from here. This is the previous output. So what is happening again? Human Pritam in Mumbai is created. Great. But then what do you see? Student Pritam created in standard 10 with roll number 20. It can access name. It can access name, which is a property of the human class. But student can also access this property. Okay. That is the magic. Can I clear this, by the way? Clear this. Control K, right? Will clear up. Let me run this again. Boom. Here we go. A human Pritam in Mumbai created. Okay, let me just show you the code once. Okay, see what's happening. So you created student S1. Okay, with these parameters, Pritam Mumbai 2010. So what is the first thing that it does? It goes to student class. It calls this constructor. Okay, you're calling the student constructor. That's simple, right? You're calling the student constructor. Student constructor takes the name, the address, the role, and the standard. Then it is calling the superconstructor, that is the humans constructor. It is calling the superconstructor and it is passing the name and the address. From here it won't go directly to this. It will stay here, and this will switch to human class. It will go. Now you have called the human constructor using the super keyword, right? This is it. And you have passed the name and the address as well. So first thing first, it will set the name, it will set the address, and it will show a human Pritam in Mumbai created. Is it showing that? Yes, human Pritam in Mumbai created. Perfect. Then it will go back to student class. And now I'll set, now this is setting its roll number and the standard. Now it is showing student Pritam. How is it accessing? Because name is a human class's property and it can access it because it has inherited human, right? It can access all these things because student is a human. Remember this, student is a human. So every property that human has, student will have those. Every method that human has, student will have those. Okay, so that's why student Pritam created in standard 10 with roll number 20. This is the flow. This is the flow. Okay, great. Should I show it visually again? Let me show you once again. I kind of like explaining as long as I can. Let me take this thing, copy. Let me go back. I should put it over here. Yeah, rather. Phew. Paste it over here. It's too big. Okay. And I need this one. I need the code of everything. Okay, entry point. Let's copy paste the entry point as well. Let's take the entry point. Okay, this is our entry point. Okay, and we'll have the student class, sorry, the human class as well. Let me just quickly copy, and let's copy till this only. I don't need to copy all these things. Just copy up to this, the constructor. Yep, only this part. Copy and go here and paste it. Yeah, this looks good. Okay, and let me again I just need the constructor at the moment. Okay, let's let it be there. Okay, no issues. Now see the flow, understand the flow, what is happening over here. Let me make this a little bit more big, since yeah, this works. Okay, look at this carefully, what is happening over here. Can I make this a little bit more big? Yeah, okay, check it out, guys. So the first thing first, this is your entry point. It's a no-brainer, right? Easy. This is your main method which you are actually running, and you are first creating the student object. You're creating a student object, you're calling the student constructor. The moment you do this, it will call the it will call the student constructor, correct? It will call the student constructor. It will pass Pritam as the name, Mumbai as the location, 20 as the roll number, 10 as the standard. Okay, great. So this is Pritam, this is Mumbai, this is 20, this is 10. Okay, great. Now the moment you do this, the next line is super. You are calling the super constructor. Oops, yeah, this one. The moment you do this, basically what will happen, the name and address. What is the name, what is the address? Pritam and Mumbai, right? And you are calling the super constructor. What is the super constructor? You are extending the human class. This is your super class. So what is the super constructor? Of course, the human constructor is the super constructor. This will then, what it will do, you will go and call the human constructor. What is the name? The name is Pritam, and the address is Mumbai. Great. It will set the name, it will set the address, it will show human Pritam in Mumbai created. Simple. Now it will come back. Now it will come back. It will come back from here. This is done, right? This is done. The moment this is done, then it will come back from this class again back to this line. You will set the roll number, then you will set the standard. Now you will show student. Now it can access this. This property is nowhere defined over here, but this property is defined over here, and it can still access this. Why? Because this is inherited. You are basically having all the properties and methods of this class. So yeah, it will show student Preetham created in standard, whatever the standard I gave, say standard was 10, right? Standard 10 with roll number 20. That's it. That is how the superconstructor and all these things work together. Hope this is clear. All right. Okay, great. So now let me go back and let me show you how you are exactly borrowing the properties and do all the magic stuff that you are doing, right? Can I push it over here or something? Okay, anyway, let's do it. So system.out.println. Let's check it out. Student has no property called name. Can I directly access it? Student does not have any name or something. Can I access it? Outside the student class. See, inside though I can access. Inside I can access the name property because I'm extending the human class, right? I'm extending this. But outside is, can I access it? Let me try quickly. Compile and again Control K, remove this, run this. Yeah, so again human Preetham in Mumbai created. That is the superconstructor. This is its own constructor, that is the student constructor, and you can access the name. You can directly say s1.name and you can access this. You can do that. Okay, this is how you can access things. And how are you able to access this? Because see this, of course student does not have its own name, that is okay, but student can access this because for obvious reason, name is a property of the human class. You can access it, but I am accessing in this class entry point. Entry point is not saying that it is extending. That is not it. It is not extending human class or something. So how it can still access the name? Because in human I have set it as public. Public means what? In the last video I have already explained. Public means you can access it anywhere, wherever you want. Okay, within the same folder, within the same class, outside of some class, inside of some subclass, anywhere. Public means anywhere. That's it. That's why you can access it within the subclass, the class that inherited you, and the class which has not inherited you. Right? You can still access the property of human. Technically, this is a property of human class. Right? And student is a human, so this is a borrowed property, not the student class's property actually. Anyway, you can do this. You can access the name. You can also access dot println. You can say s1 dot address as well. You can access these things. Now, can you do some? Let's try out some. Let's try out the student method. Let's say study, and give it some subject or something. I'm saying system.out.println s1.sum. Okay, study, and I need to pass in some. Okay, I don't need to system.out.println because anyway it will print it out, right? I don't need to specifically set print out. So yeah, study some subject, say maths, I guess. Let's compile this again. Just remove all these things, Control K, and void main this, run. Okay, see what is happening. This is the human constructor, this is the student constructor, this is the name. You can access name. You can access name, which is not the property of student class directly. It is a property that is inherited from the human class. There's Mumbai, the address. Again, it is inherited from the human class. And you are using the study method. Student Preetham is studying maths. It is working fine. This is expected, right? Student Preetham is studying maths. Great. But can I access the methods of human class? Because I am saying that student is extending, it is basically inheriting human, so it is technically a human. Student is a human, so if it is a human, can it eat, can it sleep? Yes, it can. Let me show you how. If I go here and say s1 dot eat and say burger, now this should not be allowed technically because student does not have any eat method, do we don't. But a human class has a eat method and it will use this method directly. Okay, let me just compile this. Yep, I don't know what is wrong, sometimes doesn't render in a proper way. Add Windows. Yep, just close this one, Control K, and let's rerun this once. Yeah, run this. See what is happening. A human Preetham in Mumbai created, that is the human constructor, this is the student constructor, this is the name, this is the address. Student Preetham is studying maths, that is expected, but the next method is also working. Human Preetham is eating burger, although student method doesn't, student class doesn't have any method called eat. It is still using the eat method of the human class. Why? Because it is inheriting. It is inheriting the human class. So every property, I mean that at every attribute that the human has, student also has. Every method that the human has, student also has. And it can also use the superconstructor of this. Okay, this is basically inheritance. So do you see, if I would have wrote all this code, I would have to, if I had no concept of inheritance, then I would have to write this like this. See, this is extra lines of code, right? This is extra lines of code. I would have to write say this as well. This is extra lines of code. How many lines of code is this? See, these many lines. It just counted so many lines. But using inheritance, I can cut out this part. Boom, this is gone now. I can cut out all this part. I don't need this. This is already written. And we are good. That is how inheritance saves the number of lines of code. It simplifies our programs. We don't have to write repeated code. What is already written, just take it and use it. That's inheritance for you in object-oriented programming. That's why I say object-oriented programming is one of the most beautiful paradigms in the entire programming. Now, before going any further into how many types of inheritance are there and other stuff, let's first discuss, can we always access these things like that? I mean, what about, okay, let's do this. Let's close this. What about I just do this? I mean, other than this, I can simply say private. What if I do this and I just compile this? Class compiled, no issues, right? Now, will this work? I have made this private. Now, can student class access name? Can it access can it access name and address? Can it do that? Let's try it out. This is compiled. Let's style this Windows. Yep. Close this once. Okay. It's compiled. Oh, student class is not compiled. Let's compile this. Okay. Then we have error. Why? What is this error? Name has private access in human. So basically this means that of course you are inheriting the human class. Yes, that's correct. But if human class has any property set as private, you cannot access it in your subclasses. Is that clear? If the properties are private in human class, you cannot access this. Even if you extend the class, even if you inherit the human class, even if you inherit the parent class, you still cannot access the private properties of your parent class. See, your parent has some secrets that you cannot access, that you can never access, right? These are those properties. These are private properties that which, even though you are their son, you are their children, you cannot access this. This is what happens if you do private. Oh, what about protected? What about protected? Protected. Now what will happen? Can you access this? Compile. Yep, this is compiled. Let's compile the student class. This time it worked. This time it worked. It worked. What about this entry point class? Will this? Okay, see, in protected you can access this. Yes. Remember what is protected? Protected means if you set any property as protected, it means it can be accessed anywhere within the same folder and within the subclass. Even if your subclass is in some other folder, it can still be accessed. Okay. So basically protected means it can be accessed in the same folder and it can also be accessed by the subclass. So let me try over here, compile student class. So student class can access this .name because it is protected. It can access address as well because it is protected. Great. What about entry point? Can this access this? Can this access directly the name and address? Because inside human they are set as protected. Let's compile this. Yes, no issues. Why no issues? Why no issues? Because they are in the same folder. This would have been an issue if this was in a separate folder. Then it could not have accessed it unless or until it extends this. This we will look into more depth when we study about packages. But for now, understand, you can set things as protected. The best way to set things is to keep it as protected. Even the constructor should be protected technically. Technically, the constructor should be protected because you should not allow human classes to directly create, right? That should not be the case. I mean, yeah, there are times when you need that, but the best way to do object-oriented programming is to set things as protected. If they are getting inherited by some class, if say this is a super class, this is getting inherited by student class, then things in human class should be protected. That's what I believe. But if you, of course, you need to access it directly. You need like, for example, you are accessing student class directly in this entry point. You are creating a student class, so you're basically directly accessing student, not the human class. In that case, you can set it as public. You can keep it as default, or I mean, yeah, unless or until there is some role of inheritance, like you are the super class or something, then you don't need protected because student class is not getting inherited by anything. It is the child class, so you don't need to set protected or anything like that. But since human is the super class, then I would go with the protected access specifier. At least that's the approach that I use, but you are free to use whatever you like. If you think that freedom is the thing that you like, then yeah, of course, go ahead and set this as public. Yeah, you're good. No issues at all. You can set this as public as well. If you don't set anything now, this is basically the default access specifier. So it's better that you set it like this. Do give it an access specifier, even though you are writing say a constructor. So now that we are done with playing around with private and public, and yeah, it is the same for this as well. Protected and all. Okay, this is the same thing. Okay, we will learn more about these things when we study about packages. For now, this is the thing. So we are done with how access specifiers work in inheritance. We are done with how inheritance works in general, how we are borrowing the attributes and the methods, how we are reducing the lines of code, how things are working or not. I can use the human classes methods eat and sleep via the student class, although I haven't written the method. Right, I can do all of these things. I am creating a student s1 object and I'm saying, hey, eat burger, although I haven't declared anywhere in the student class to eat burger, but in human class I have defined, so it is using this method, right? So this is inheritance. Now we will check out the types of inheritance. Okay, and I would suggest you to go through this. Okay, anyway, I will do this as well. This is again a single inheritance example where developer basically a software engineer is inheriting the human properties. Again, human has eat and sleep. This will be automatically inherited by the software developer, because again developer is a human, right? If you're a software engineer, you're first a human, then a software engineer, right? So of course you can eat and sleep. Of course you have a name and address, right? Of course. And then you have your own properties as well. I mean, if you're a software engineer, then you can code and debug things. You have a role, you have a company, you have a programming language that you use daily. So yeah, this is again inheritance, right? And yeah, we will create that. We'll create that. This is already created. We'll be creating the developer class as well, and we will play around with it. So the next thing is that yeah, so as I was explaining, say for example you have the developer class, you have the student class, and there is the human class, and student is inheriting the human class, and developer is also inheriting the human class. So who is the super class, who is the subclass? Since student is inheriting the human class, it is the subclass or the child class Developer is also inheriting the human class, so again it is the subclass or child class. It can be done, pretty easy to do. Okay, and who is getting inherited, by the way? This class. That's why it is the super class. Okay, let me quickly create a developer class quickly. Let me compile all these things, compile, and yeah, compile this as well. Yeah, let's do one thing. Let me put it over here. Yeah, and let me quickly create a developer class. So done. Let me put it at the same level. Yep. Let me just remove all these things. I don't need these things. Remove. I will be, by the way, inheriting the human class, just like I showed you, right? Developer will be inheriting the human class, right? I mean, I'm using this example. So let's quickly do that. How do we inherit something? We say extends human. That's it. See, did you see that? A new arrow created. Student class is inheriting human class. Developer class is also inheriting human class. Okay. Let's quickly create some of the properties. What are the properties, by the way? Let's quickly recap. Okay, so eat, sleep, name, address, we don't need to define. It is already defined in the human class, so skip that. Other than that, code. Okay, code is a method, debug is a method. Role, company, and language. Okay, role, company, and language. These are all string, and these are just void void methods that will just say, hey, this guy is coding. So yeah, quickly write that. I can say public string role, company, and what? Language. Yep. And it will have a constructor as well, which is the developer constructor. Okay, first of all, it will take the name and address, although it doesn't have any name and address, but yeah, it is a human, and human has a name and address. So anyway, it will take a name, it will take an address, it will take a role, it will take a company, it will take a language. Yeah. And yeah, let's start. Of course, it will call the superconstructor. And superconstructor is what? Humans constructor. Basically, this guy over here. It will take name and address. You're taking it from the developer's constructor anyway. So just pass in the name and address. Just pass in it. Good. Now just simply set the things up like, yeah, see, did you see it saved the code? You don't have to separately set name and address and stuff. It is already done. Just set whatever is required for your class, that is developer. So role, company, and language. So this dot role is equals to underscore role. This dot company equals to underscore company. This dot say language is equals to underscore language. That's it, done. And yeah, let's for now system dot out dot println, just say developer, just write the name, this dot name works at whatever the company name is. We just quickly do this. Works at, in a space, works at the company name, this dot company as a, or whatever the role is, this dot role, and uses this dot language. Okay, these are the properties. And of course we can create a dummy method, say public void code, and simply say system.out.println developer, whatever the name is, this dot name codes in whatever the language is, this dot language. We're done. Let's compile this. Okay, compilation done. Close this. Let's open the entry point quickly, and yeah, let's create a developer now. Developer dot developer d1 is equals to new developer, and yeah, it takes the name, and again let's say Raju, and let's give it an address of Indore. He works at, okay, what are the things that this is expecting? Okay, this is expecting a role, a company, and a language. So the role would be as software development engineer, SDE. The company would be, say, Google, the dream company of every engineer, and language would be, say, Java. Okay, simple. Let's create this and say d1 dot eat pizza, and also d1 dot code. Simple. It doesn't expect any arguments with this. Only compile this. Do you see this now? Do you see this? Entry point is now creating a student object and a developer object, and developer class anyway is extending the human class, inheriting the human class. Student class is also inheriting the human class. Perfect. Let's run the entry point quickly. Void main, run this. Okay, what is happening? Okay, this part you already know. Human Pritham is in Mumbai created. Student Pritham created in class 10 with roll number 20. The name is Pritham. The address is Mumbai, and he is studying maths. And okay, like, yeah, we have done this, right? No problem. Let's see the other part. It is creating a developer object. What it is saying? What is the first line saying? It is calling the developer constructor. Developer constructor, on the other hand, is, by the way, calling the superconstructor. What is superconstructor? Of course, the humans constructor. Basically, this one. It is showing up a human Raju in Indore created, right? A human, yeah, this one. Human Raju in Indore created. Perfect. It is working, right? Developer is calling the humans constructor. Humans constructor is taking the name and the address and setting it up and saying a human Raju in Indore created, because you have passed in you have passed in as Raju and Indore as the name and address. Then it is showing developer Raju works at Google as the software developer engineer and uses Java. How it is showing? Because in developer constructor, by the way, okay, this is superconstructor. After this, it sets the role, sets the company, sets the language, and then shows up developer Raju, whatever the name is, works at this company, which is Google. I have set as a whatever the role I have set, and uses that language, whatever I have set. So this is showing developer Raju works at Google as a software developer engineer and uses Java. That's it. Now I am doing d1.8 pizza. Now nowhere in this class I have defined any method as eat or sleep or anything, have I? No, right? I haven't defined name or address, right? But it is still using the properties of the human class and the methods of human class as well. I can directly say Raju is eating, and of course developer doesn't have any eat method, but it will come here. Whatever the superclass is, the superclass is human. It will come here. It will search for the method, and yes, you will find the method eat. It will pass the food. What have I passed? What have I passed? I have passed a d1.8 eat pizza. It will show Raju is eating pizza. Yes, it is showing. It is showing Raju is eating pizza. Then I am saying d1.code. Now code is a method of its own. I have defined this method, and this will show Raju codes in Java. That's it. See. Do you see the number of lines of code that it reduces? You don't have to write the same methods again and again. Think about it. Think about this. If I had to copy and paste all these methods in both developer, I mean over here. Not yet. Hold on. Say I have to copy this and put it over here, and then we have the student method as well. Paste it over here as well. Do you see how the number of lines, like how many lines of code we had to write if we didn't have the concept of inheritance? We can simply define it somewhere, and we can just extend this class, and we can just inherit this, and we can just remove all these things. I mean, we don't need this. Just remove this, and we're good. Just remove this, right? This is saving the lines of code because this is already defined in human, and you can directly use it. Congratulations, this is inheritance for you. And this looks pretty neat, by the way. This map looks pretty neat. Now finally we will be going into the types of inheritance, and congratulations, you have already done 2 types. The first one, when there is only, say, there is no developer class, right? Just the student and the human class. The student class is inheriting the properties and methods from the human class. This is called single inheritance. But when there's one class, one superclass, and multiple classes are inheriting the class, this is called hierarchical. This is called hierarchical inheritance. And there are 2 more. One is allowed. One is not allowed by Java. I'll show that in Python. And one is allowed by Java, which I have already shown you, by the way. Which is this: you are inheriting from some class, but your superclass is inheriting its own properties from some other class. This is called multi-level inheritance. We have already gone through all these things, but anyway, I'll go through this once more, and I'll give you the examples as well. So multi-level we have done, we have seen, right? You are the son, you are inheriting your properties and methods from your father is inheriting the properties and methods from his father, which is your grandfather. Single is basically, say, this is the developer, this is the human. Developer is inheriting properties from human. Simple. Multiple would be like that. Multiple is not allowed by Java, by the way. It is not allowed by Java. Okay. And hierarchical we have done. One class inherited by multiple. For example, this is a PC, computer. It has a CPU, mouse, keyboard, whatever. Now you have phone. Phone has inherited the properties of its own from PC, from the computer. It has a keyboard, it has a screen, it has a CPU, it has a GPU, whatever. And you have laptop as well. Again, laptop is also inherited from its properties from the PC. It has a keyboard, it has a screen, it has a GPU, it has a CPU, etc. This is allowed by Java. This is allowed by Java. In multiple, think about this. Say this is a robot. This is a robot. And how do we create a robot? Well, a robot looks like a human. It has a name, it has address, blah blah blah. And it is also a computer, because basically it is like a human which has a computer within it. So it is inheriting from multiple classes. This is not allowed by Java, but it is allowed by languages like Python and C++, and I will show you the demos. So the first type of inheritance is called single inheritance, and we have already looked at single inheritance. It's as simple as this. Say, for example, you have a class A and you have a class B. Okay, class B, and class B extends class A. Extend means class B inherits class A. Okay, class B inherits class A. This is called single inheritance. As simple as that. And we have already looked at that example, right? Let me again just draw it. Okay, so we have class A and we have class B, and simply speaking, class B is inheriting the properties and the methods from class A. This is called single inheritance. And we have already looked at the examples. You can implement those for your own practice. So say you have the human class. Okay, let me use the same color. So say you have the human class, and then you say you have the student class. Okay, and simply speaking, student class inherits from human class. This is an example of single inheritance. Okay, right? Correct? Great. But only this. If there is just a single class inheriting another single class, this is called single inheritance. Who is the subclass? Who is the superclass? Of course, this guy is the superclass, or the parent class, whatever you are comfortable with. Parent class, and this class is the subclass or the child class. Okay, that's simple. Say for example, we also have human. Forget about this, by the way. Forget about this. Say we just have the human class, and we have the developer class, right? We already did this example. Developer class, right? This is again single inheritance, right? There is only one class, there is another class which is inheriting this class. This is single inheritance. That simple. This is the superclass, this is the subclass, and we are done. This is single inheritance. What is the next type of inheritance? Well, the next type would be, let me open up, would be hierarchical. Okay, so hierarchical would be, there is a class A. Okay, and then we have say class B, and we have class C. Okay, now class B extends class A, class C also extends class A. This is the classic example that we saw while implementing inheritance. This is called hierarchical inheritance. Hierarchical inheritance. Okay, and like I already said here, this part is single, this part is also single. Okay, individually they are single. Here, say developer extends human, this is single. Students extends human, this is also single. But the common thing is, when you combine both of them, do you see what is common? A human is common. When you combine both of them, if you don't combine, they are like simply this is single, this is single, this is single. Okay, but when you combine both of them, this becomes hierarchical. How? Because there's only one human class, then there is the developer class, and then we also have the student class. And both of them inherits from human class. Developer also inherits human class, student also inherits human class. Now this combined, when you combine both of them, then you get hierarchical. So basically, hierarchical, in other words, you can say combination of single inheritances. You can simply say combination or I could say collection of single inheritance from a common parent class or superclass. Parent class. Why did I say collection of single inheritance from a common class? Because if you just take human and student, what is this? This is single, correct? If you just take a human and developer, what is this? This is single. But when you make a collection of it, like when you combine all of them, you have the common parent. You have the common parent, and this is called hierarchical inheritance. So there is a class A. This is the superclass, and then you have multiple, not just two. You can have many more. You can have many more classes. You can have a teacher class. You can have a doctor class. Whatever. You can have multiple, but look at them carefully. Doctor and human, single, correct? Teacher and human, single, correct? But doctor, developer, student, teacher, all single, but when you combine all of them, it becomes hierarchical. Okay, that's why it is called hierarchical. And these are the subclasses. Subclass, this is again a subclass, and there can be many subclasses, many more subclasses. This is hierarchical. Now another example would be the classic, grandparent example, which I'll show you. Maybe in polymorphism I would show you, but just know that this is hierarchical. Now moving on to the next type, this is called the multi-level inheritance. The multi-level inheritance. Again, this is a combination of single. Again, this is a combination of single inheritance. For example, say you have a class A. Then you have a class B. Okay. Now class B inherits class A. Great. This is single inheritance. But you have another class called C, and class C inherits from class B. This is single, and this is also single. But when you combine these things, okay, when you combine these things, it becomes what? It becomes multi-level. Why multi-level? Because it has multiple levels. This is level 0, this is level 1, this is level 2. It has multiple levels. So who is the superclass? Who is the superclass? Who is the subclass? See, this is definitely subclass. This is both a subclass and a superclass. Not or, and a superclass. Why so? See, this is superclass for this. This is superclass for this. Okay? Subclass, superclass. But this is subclass for this. Right? This is superclass only. This is only superclass. This is only subclass. But the guy in the middle, this class, is both a subclass and a superclass. Why so? Because class C is of course a subclass. It inherits from another class, that is class B. That makes class B the superclass. But class B is also a subclass. Why? Because it inherits from the superclass class A. This is called multi-level inheritance. Alright. So should we have an example of this? Maybe we can have an example. You remember the first example that we had taken? This one? Actually, you know what? We can implement this. We can actually implement this. Let me open BlueJ once quickly. So this was a classic example of what? Hierarchical inheritance, right? Because we had the human class, we had the developer class and the student class, of course, right? This is what? This is hierarchical inheritance. Correct. Because you have only one parent class. Ignore this because this is not a part of this thing. But the inheritance is basically this: student, developer, and human. Student and developer both inherit the same class. This is hierarchical. We have already seen this. So moving on, let me delete all of these things. I don't need to keep these things at the moment, at least. We just remove this. Boom. Doesn't work that way or what? Let me delete this. Remove. Yep, remove. We need to modify this entry point once, because now we don't have all these things. So just remove this, compile this at the moment, and let's create some new few classes. Let's create a grandfather class. Oops, wrong name. New class, say grandfather class. Then we have, oh okay, this is grandfather. Then we have, say, the son class, that is the son of the grandfather, of course. That means your father, or let's call it son father. This is a son father class because this is a super class and a subclass. Okay, son father, and then you have the son class, only the son class. Okay, this is the son class, and here we go. That's it. We have these things, right? Let's quickly implement this. I won't go into a lot of detail, but yeah, let's just do it. I mean, why not? But again, I mean, do you see all of them are human? I shouldn't have deleted the human class. But anyway, I should have inherited the properties and all. But anyway, let's keep going. Let's keep going. Now let's use the grandfather class. We won't be defining any constructor methods over here because, well, I mean, I'm just interested to show you right at the moment that how this works basically. Okay, so say we have a method public void play flute. So basically the grandfather can play flute. So simply say system.out.println playing flute. Okay, end of the story. So that's it. Finish. That's it. That's our grandfather class. Let's compile this, and we are good. Let's close this. Okay, we are done. Let's go to son father class and say that the son father class inherits. This inherits. Where should we go? Oh, sorry. Extends grandfather. Okay. Let me just remove all these things and also write, and let's have another method public void play piano, I guess. Piano. Yep, play piano, and system.out.println playing piano. Okay, simple. I have this method, and let's compile this. We are done. Let's go back. Do you see this is a single inheritance now? Let's go to this thing and just remove all of these things. Son inherits the son father class. I mean his father, right? Extends son father. Hey, am I putting the name correctly? Let me check once. Yeah, it is son father, right? It is son father. Oopsie. Yeah, it doesn't matter. I mean, just remove all these things. Can I bring him on like this? Yeah. Yeah, this looks nice. Nice. Perfect. Okay. So son father extend. And now the son only has one method. Public void. Say play guitar. And system.out.println playing guitar. And done. Let's compile this. This is multi-level inheritance. Now let's go to entry point and let's play around. Okay, let's play around. Let's create this object. Okay, let's first create grandfather object. Okay, grandfather g1 is equals to new grandfather. We don't have any constructor defined, so yeah, this is the default constructor. That is done. It is done. Let me rather put it over here just for symmetrical. Yeah, okay. We have created this. Now what if I say g1 dot, what was the method again? Sorry, not this one. What was the method? Play flute. Okay, play flute. See if I say g1 dot play flute. Simply this. And let's compile this. What, doesn't work? Oh, just a typo. Yeah, now it should work. Compile this. Now it's done. Let's run this. Playing flute. Great. Okay. So grandfather can only do one thing, that is play flute. Great. Let's now have the son father class. Grandfather can only do one thing, that is play flute. That's it. But what about the other classes? Say for example, if I say son father, I mean I'm talking about this class. Son father. Okay. Son father sf is equals to new son father, again the default constructor, and now look at this. Sf dot, what could son father do? Technically speaking, son father could only play piano. This is the only method it has. If I say play piano, this will of course work, but along with this it has the grandfather's property as well, which is basically playing the flute. So I can also go ahead and say sf dot play flute, and this will also work. Compile this, and now let's try running this. Oops. Yep. Let me control K this once and again run this. Run. Now do you see? Play piano, of course it is working. Because it is his own method, right? It will anyway work. But point is, play flute will also work. Why? Because it is extending the grandfather class, and grandfather class of course has this method. So any property that the grandfather class, any method that the grandfather class has will be available to son father class as well, as long as it is public, of course. So it is available. We can use that. Single inheritance, basic simple thing. Okay, let's go back, and we are done with this son father class. Now let's play around with this son class, who is inheriting from the son father class. What about this now? Let's say I say son s1 is equals to new son, again default constructor. I didn't define anything. Now let's play around. What could the son do? Of course, son could play guitar. Very good. Let's play guitar then. I can simply say s1 dot play guitar, and then I can say s1 dot play. He is inheriting his father. He is inheriting his own father. His father could play piano. I can go ahead and say play piano. This will also work. But important thing is that the son can also play flute. Why is it so? Because this is anyway getting inherited by his father, and his son is inheriting from his father. So any property that the father can access, the son can also access. Getting the point? So when I say ultimately that he can play flute, it is possible. Let's do that. S1 dot play flute. Let's compile this. And yeah, let's remove all these things. Let me run this once more. Yeah, it is working. Great, amazing. So he can play guitar. This is his own method. He can play piano. This is his father's method, which he is directly extending. And this is playing flute, which he is not directly extending, but his father is extending. So by that, he is also extending. That's how multi-level inheritance works. Okay. Let me just, yeah. So basically, if I just copy this, this is the classic example of multi-level inheritance. If I just paste it over here, yeah. So the important thing over here is that the son directly inherits his father. Okay. Now listen to my words very carefully. Directly inherits its father's properties and methods, right? But he is indirectly inheriting his grandfather's properties and methods as well. Why? How? Because the grandfather, I mean the son father is extending the grandfather. So any property that this has, this also has. And he has his own properties, right? He has his own properties. Now when the son is extending his father, of course he will have his father's properties, but since the father had his grandfather's, I mean his father's properties, he will also have them. And of course he can have his own properties as well. So yeah, this is how multi-level inheritance works in context of object-oriented programming. Now we can play around with all sorts of classes. We can, if we talk about multi-level inheritance, we can play around. We can say there's a human, then there's or we can do something like this. We all are mammals, right? So we can say mammals, then we can have a human, then we can have a student. Play around. Just make your own classes, try them on your own. Mammals will have some methods like reproduce, sleep, eat. Human will have a name and a location. Student will have a class, a roll number, I mean a standard, a roll number, a subject, method called study. Play around with these things. You can make your own examples and make some classes and try it on your own. That will just enhance the thinking capability of yourself, right? Now the next type of inheritance is called multiple inheritance. Multiple. By the way, this is not allowed in Java. This is not allowed in Java. This exists in languages like Python, C++. This exists. Okay. Python, C++. This will exist. What is multiple inheritance? Kind of opposite, just the opposite of hierarchical. In this case, what happens? Say there is a class. Say there is a class A and there is a class B and there is a class C. You know what happens? Class C inherits both class A and class B. A single class inherits multiple superclasses. Single class, let me put it in a more bold way, single subclass inherits from multiple, that's why it is multiple inheritance, multiple super classes. This is called multiple inheritance. This is of course the subclass, this is superclass, this is another superclass. Okay, what can be the example? What can be the example? Well, let me think. I mean, you inherit from your father and your mother, so you can think of it like this. I mean, you can have a father and you can have a mother, and this is you. I mean, the child. Now, the child will inherit the attributes and the methods of the father and the attributes and methods of the mother. Simple. This is how multiple inheritance works. Okay, but this is not allowed in Java. How can you, so how can we achieve the same scenario? There is something called interfaces which is out of the scope, at least at this moment, but we can almost achieve multiple inheritance using something called interfaces, which is out of scope at the moment. But I will show you the real multiple inheritance using Python because it is my primary language. I'll just give an example in Python. For this example, by the way, we would be using let me open this. Oops. Let me go back. Yeah. So we'll be actually using this example only. We'll have a human class. We'll have a I mean the computer class. Okay, and then we'll have the robot. I guess that would be use case for this, right? Great. So I have to open the Python. Let me open the VS Code quickly. Okay, this is all Java. Let me just close all of these things. Let's create a Python file. Say example.py. Example.py. Okay. Oops. So in this example.py, let's create our first class. Say class computer. Okay, let's have a computer class. This is how we create classes in Python, by the way. And we will define a constructor. We don't explicitly define the properties. We define all the properties within the constructor in Python. So def init. This is how we define the constructor. Okay, we write self. Self is basically the this keyword. You have to write this in the constructor. This is how Python looks like. Anyway, what are the properties? The properties would be a computer's property. So RAM and storage and the processor. Okay, and yeah, let's not add underscore for the moment. Let's keep it simple. Okay, just keep it simple. Yeah, and just do whatever you have done till now. This, oh sorry, not this. Self dot RAM is equals to RAM, whatever the user provides, or not semicolon. Python doesn't have any semicolon. Self dot storage is equals to storage, and self dot processor is equals to processor. Done. Okay, then let's say print and simply say computer created Same thing, just same thing. Computer created with, you know what, I'll do it the easy way. This is the printf. You remember printf in Java? The way we were using the printf, it works almost like that. Computer, but easier than Java, of course. Created with self dot RAM, GB of RAM, GB RAM, um, and self dot whatever the storage is, storage GB. Actually, I should add a space over here. GB of storage, that is the hard disk basically, and processor, self dot processor. Okay, done. This is the constructor. It can work. It can start, def start. You can simply start, and yeah, that's it basically. Just simple print computer or processor activated, something like this, and it can shut down as well. Def shut down. Computer can shut down, right? Print okay, that's it. This is our computer class. Let's have another class now. Let's have class human. This is another class. We again have a constructor. What are the properties? Properties would be, of course, name. Just the name, right? Okay. Self dot name is equals to name, whatever the user provides. A human can speak, print a string. Hello, I am whatever the name is, self dot name. Yeah, right. We have to self this. Yeah, we always have to do this self. Otherwise, it won't work. I know it's weird, but yeah, it is. It is what it is. Hello, I am. Okay. A human can speak, and a human can walk. Oops, walking around. That's it. Now let's have another class. Class robot. Now robot will extend computer and human, both. Computer and, I mean, you just put a comma over here in Python, and the human class, so it inherits both of them. And uh what it will do is this: def init Now the important thing is that we know what superclass is, and we can of course call the superconstructor. This is basically calling superconstructor. But there is a problem. You know what is the problem? The computer cannot decide which is the superconstructor. It cannot decide. I mean, Python cannot decide who is the superconstructor. Why so? Because it has two superclasses, right? It has human class and the computer class. So when you are talking about superclass, what do you mean? What do you mean? That is the problem. You cannot just simply write in a superclass. Call the superconstructor. It doesn't know which superconstructor because it has two parent classes. This also has a constructor. This also has a constructor. So when you are saying super, which constructor do you mean? So you cannot just directly do this. Rather, oh, by the way, if you directly call, if you try to do this, by the way, what will happen? Will this give you a compilation error? No, it will not. You know, the first class that is getting inherited from left side, which is the first class that is getting inherited from the left side, that is computer. When you are calling super, it means this class and not this class. So it will not work properly. So you remove this line. Instead, specify explicitly. Oh, and by the way, you have to take the name as well, right? So take the name as well. And now say human dot underscore init. So you're specifically saying that I am calling the human constructor and pass the name. That, and exactly that is the reason this you cannot do. You cannot do in Java. That is the reason Java will not allow multiple inheritance. Java can only do super. It cannot specifically say that computer or human or any other class. You cannot do that. That's why it is not allowed in Java. This is the only reason. Okay, anyway, you pass the name and then you say I am calling the computer's constructor and pass in the RAM, pass the storage, RAM, storage, and the processor, and done. Simply. And what are your own properties? I mean, you're a robot, right? What are your own properties? A robot's name and computer. I mean, let me think. Build quality probably. Yep. Or manufacturer. Yeah, manufacturer. Manufacturer. And maybe version, something like that. I mean, this is all made up, right? So I can say self dot manufacturer is equals to manufacturer, and self dot version of the robot is equals to whatever the version is given by the user. That's it. What can be his own methods? A robot can dance, I guess. Yep. A robot can dance. Div dance self print robot dancing. And yeah, that's it. Let's try to compile this up. Oops. Example.py. Oh, it of course I didn't do anything, right? I need to define the main method as well. But Python might have a main method or not. That depends. But yeah, let's create a robot object first. How do I do this? It's as simple as Java. Just say x is, in fact, more simple than Java. Say r is equals to, or just say robo is equals to robot. Just call this and just give him the arguments that is that, like the parameters that it is expecting. So just say maybe Chitti, and RAM would be say 64 GB, 64 GB. Storage would be maybe 10,000 GB. RAM should be rather, 256 GB RAM. Yeah, it's a robot, come on. And it has a processor of, say, Intel i9. And I guess we are good. Let me do robo dot what? Robo dot dance, robo dot. Actually, you know what? Robo dot start, robo dot dance, robo dot. What were the human methods, by the way? Speak. Yep. Robo dot speak, robo dot what? Work, robo dot shutdown. Yep. So this method is coming from, okay, comments in Python looks like this. This method is coming from the computer class. This method is coming from its own class, robot. This is coming from a human class. This is also coming from a human class. This is coming from computer class. Do you see? This is how we can do multiple inheritance. Let's save this up and let's run this. Oh, did I miss something? Okay, okay, lol. I forgot the manufacturer and the version. Say the manufacturer is what? Manufacturer is maybe Bosch. This is actually a manufacturer. I'm not making up things. Version, say 4.2, something like that. Save this and try to run this. What? I did mention, right? It's not working. Oh, did I forget self something? Let's fix it. Should fix it. Yep, it is working. I forgot to put up self here. Anyway, now do you see when I create a robot, what's the first thing that it says? It says computer created with 256 GB RAM, 10,000 GB storage, Intel i9 processor activated. In fact, you know what? I should also add something over here. You can say print a human self dot name created. Yeah, this looks good. Let me just quickly run this once again. See what is happening. The first thing that is happening is human chitti created. You're creating a robot. Think about this. You're creating a robot. Okay. So you can see human chitti created. So this is the constructor of the human class. It is working perfectly fine. Then you can see the constructor of the computer class working. Computer created with 256 GB of RAM, 10,000 GB of storage, Intel i9 processor. It is working. So both of the things are created. The human object is also created. I mean, it has the constructor of the human. It is been called. It has the constructor of the computer. Both are done. Now, robo.start. You can see processor activated. Although I haven't defined the method anywhere in the robot class. Have I? Have I defined the start method over here? No, it is coming from the computer class. This is where I have defined the start and shutdown method, right? But still working. Robot dancing. This is his own method, of course. I have defined over here dance, so it is perfectly fine. Hello, I am Chitty. What is this method? Robot.speak. I haven't defined the speak method anywhere in the robot class, did I? No. It is defined in the human class. This is done. Then what's the next method? I'm saying robo.walk. The moment I do this, it says walking around. Again, this method is nowhere in the robot class. It is defined in the human class, walk method. Then finally, I am saying robo.shutdown. The moment I do this, it says processor shutdown. Again, I haven't defined anywhere in the robot class, but it is coming from the computer class, that is shutdown. Okay, Let me just take a quick screenshot just for your visual understanding. Let's go back. Okay, this is the computer class. Let's go back. Let's take a screenshot of the human class as well. And paste this up. And just okay, this is the human class. And finally, you have the robot class. The robot class. And the creating of the I'm creating the robot object. Just paste it over here. So again, this class is inheriting both the computer class, that is this class, and the human class, that is this class. This is called multiple inheritance. Okay, now it has to specifically say I'm calling the human constructor, that is this one, or I'm calling the computer constructor. Sorry, it has to specifically say. Let me put the arrows in a better way. So yeah, it is inheriting the computer class and it is inheriting the human class. Perfect. Now I have to specifically say that I'm calling the human constructor, that is this one, and I have to pass name, which is required by the way, and I'm then calling the computer constructor. Okay, I'm then calling the computer constructor, that is this one, and I'm passing the RAM, storage, and processor. Good. Now it has its two values are its own properties, manufacturer and version. So yeah, I'm setting that up. That's it, done. It has its own method dance. Now when I'm saying when I'm calling the constructor, I'm passing all these values: the name, the RAM, the storage, the processor, the manufacturer, version, everything. But the first thing that is getting called is human constructor, and that is why, my friends, let me put the output as well. Let me paste it quickly over here. Oops. That is the reason, guys, that the first thing, the moment we create the constructor, the first constructor is human constructor. That's why we are getting human kitty created. Then we are calling the computer constructor, and that's why the second thing that we are getting is computer created with 256 GB RAM, 10,000, like whatever we have defined over here. We are getting that, right? The next thing is that what robot.start. Now start is defined in the computer class, that is this method is getting called processor activated, right? We're getting this. Then we get robot.dance. Dance it is his own method. So yeah, robot dancing, we get robot dancing. Then I say robot.speak. This method is getting called from the human class, and it should say hello, I am Chitti. Like I have defined it to say hello, I am whatever the name is. Then robot.walk. Walk method is defined again in the human class, and it should say walking around. You can say over here it is saying walking around. Great. Finally it is saying robot.shutdown. Shutdown is defined within the computer class, this one, in the computer class shutdown method, and it should say processor shutdown, and it is exactly doing that. That's it. This is multiple inheritance. That is how a single subclass can inherit multiple superclasses. These are the superclasses. This robot is the subclass, and it is not it is not allowed in Java. It is only allowed in languages like Python and C++. There are some other languages which allow this. But yeah, guys, that is it. That's multiple inheritance for you. And with that, we conclude this chapter. A quick recap: single inheritance. There's only one superclass. There's only one subclass. Subclass is inheriting the superclass. Done. Multiple inheritance. We just learned there's one subclass, but there are multiple superclasses. Like the example that we just did, the robot and the computer class and the human class. Great. Multi-level inheritance. We have the son, we have the son father, we have the grandfather. Son is inheriting from the son father is inheriting from the grandfather. That is multi-level. Hierarchical, we haven't used this example, but yeah, this is the PC. It has a RAM, it has a processor, it has a monitor. This also has a screen, a keyboard, and a mouse, right? Mouse, basically you are touching the screen, so yeah, that is your mouse. Again, this is inheriting from the PC. It has a RAM, it has a GPU, it has a CPU, it has a monitor, it has a keyboard, it has a mouse. So yeah, this hierarchical. Another example of hierarchical would be, I mean, if we just go around and look at this is hierarchical again. This is the human class, this is the student class, and this is the developer class. So this is the subclass, this is the subclass, and there is only one common parent. This is human class. So with that, we conclude our chapter of inheritance. Hope you have understood it. If there are any doubts, just let me know in the comment section. And in the next video, we will be talking about something called polymorphism. And till then, bye bye.